So the next chapter is electric field. So point number 1 is force of attraction or repulsion between charges is called electric or electrostatic force. So the force of attraction or the repulsion between the charges is called electrostatic force. Now, according to Coulomb's law, electrostatic force is directly proportional to the product of two point charges and inversely proportional to the square of distance between them from their centers. So it's similar to the Newton's law of gravitation, but the difference is mass and charge. So here, charge. Electrostatic force is directly proportional to the product of 2-point charges and inversely proportional to square of the distance between them from their centers. So electrostatic force mean electric force directly proportional to Q1 times Q2. The product of the charges mean the both charges will experience the same force because the force is depending on the product. Whether the charge is small or large, both will experience the same force. And number 2, this electric force inversely proportional to distance square. Mean inverse square law is valid. When the distance becomes double, force decreases by 4. When the distance becomes 10 times, force decreases by 100 times. Inverse square law. When both relations are combined, then electric force is directly proportional to Q1, Q2 over d square. Now we have to write here the constant. So look, F electric, K constant suppose, Q1, Q2 over d square. It is similar to force of gravitation G, M1, M2 over d square. This K is called electrostatic constant. And this K, electrostatic constant, further equal to 1 over 4 pi epsilon naught. This symbol is epsilon naught. And epsilon means the permittivity, the degree of permission for attraction or repulsion. And epsilon naught mean the permission from the vacuum, from the free space. So this is epsilon naught is the permittivity of free space. Free space means the vacuum. Means so in A level, we will assume that all charges are kept, all charges are placed in vacuum. So that's why this K is equal to 1 over 4 pi epsilon naught. So this is the assumption in A level. Okay, so all charges are kept in free space, mean the vacuum. So 1/4 pi, and its value will be given. Whole value for this is equal to 8.9 into 10 power 9 approximately. It will be given on the paper. So we can write this electrostatic force 1/4 pi epsilon naught Q1 Q2 over d square. This is the Coulomb's law equation. Okay, now after this electric force, there is electric field strength. Which is a vector, and it's represented by E. According to A's definition, electric field strength, it is electrostatic force experienced per unit test charge in the electric field. So I repeat, electric field strength is the electrostatic force experienced per unit positive test charge in the electric field. So formula, E electric field strength is equal to F divided by Q. This F is the electric force. This Q is the test charge, and the test charge is considered positive. Now, E is equal to this electrostatic force according to Coulomb's law is 1/4 pi epsilon naught Q1 Q2 over d square and divided by Q. Now, remember, one of the charge is point and other is the test. In this product, one charge will be considered point and the other charge will be considered test. So suppose this is test charge and it is cancelled with the test charge. Suppose Q2 is test charge, you can take Q1. Then the electric field strength formula is equal to 1/4 pi epsilon naught remaining charge, which is the point charge, divided by d square. So this remaining charge is definitely the point charge, and the point charge which exerts force, and the test charge which experiences force. So this is the formula for electric field strength. Now, electric field strength is a vector, force is a vector, both are acting in the same direction. Both are parallel to each other. Now, suppose we have this metal sapphire, any other sapphire, and it is charged. If it is solid inside, then all charges will appear under the surface, beneath the layer. All charges are kept by the surfaces, but if the solid sapphire, then the charges will appear beneath the surface, mean here. Because the mass of the solid is concentrated inward, so the charges will appear inner surface, inner layer of the surface. This is solid. It means there is no charge inside. So when there is no charge inside, Q0, so from the above equation, then E inside is also 0. Similarly, if your charged sapphire is hollow inside, this is the solid and this is hollow, then the mass is concentrated towards the edges. Then all charges will appear above the surface. They are kept by the surfaces, but beneath or above, it depends on the solid. Solid inside the surface and hollow outside the surface. Now again, no charge inside. So no electric field inside, electric field strength inside. It means the electric field starts from the surface of the charged sphere. And at the surface, this electric field strength is maximum because this is the starting point. So its formula will be 1 over 4 pi epsilon naught point charge divided by d square. In physics, all distances are measured from the center. So center to the surface, it is radius. So we will write r square. And similarly, for this hollow sphere, E is again is equal to maximum at the surface. So it is 1 over 4 pi epsilon naught, this point charge again divided by r squared. So this is the distance r. In physics, all distances are measured from center. So surface is at the distance of r from the center. Now suppose we have to draw electric field strength against distance graph for isolated charge sphere, d distance. This is the center, this left side as a right side, and this left side of the center. Distance measured in meter. Electric field strength is measured either in Newton per coulomb or volt per meter as AS. Okay, we have done. Now, this is center. So this surface is the right side radius, and this surface is the left side radius. So inside the sphere, there's no electric field. So from left to right radius, the electric field strength is 0. But at surface, exactly at the surface, its value is maximum. Either maximum. So this is a maximum. Look, Emax at R. Now, according to the relation, E is inversely proportional to D squared. So away from R, this E decreases. E decreases. So this is the electric field strength and the distance graph for a charged sphere, which is positively charged. So electric field strength is maximum at the surface and then gradually decreases, inversely proportional. This is E and D graph for the isolated charged sphere. Now suppose we have another charged sphere which is negatively charged. For this, we can draw it like this. It is a vector. This is d scalar, d scalar. This is radius. This is radius. So between both radii, it's 0. At the radius, it's maximum due to the negative, it's opposite direction. Negative, opposite direction, and then inversely proportional. This is the E and D graph for the negative charge. Now suppose we have two charged spheres. For example, one charged sphere is positively charged and the other is negatively charged. This positive and negative sign doesn't mean the charge at the center. Thus the polarity showing just definitely the charges will be at the surface in both. But this is just a symbol that is positively charged, it's a negative charge. Now the resultant electric field strength. So first we draw the electric field. So field lines are directed outward from the positive charge and inward towards negative charge. Now, at the surface, this point, this P, and at this point, Q, the electric field strength is strong, but this is the line, suppose this is R, where the electric field strength is minimum. Now we have to draw the graph for this. So this is the center of the positive charge, this is the center of the negative charge, and this is the mutual distance, D. And this is E, electric field strength, and here D. Now at the surface, I mean here at the R, electric field strength is maximum directed towards the positive side. So it is maximum and positive. Here at the surface, it is maximum also directed towards the positive side. So the direction also positive. But this is the point, this is the line where the field is weak, small, minimum, but not zero. So suppose this is the value. So this is the graph of E and D between positive and negative charge sphere. From the center of the sphere to the surface, it's 0. Center of the sphere to the surface, 0. At the surface, both sides maximum. Both are directed in one direction. So positive, positive. And here it's minimum. Now, next. Both spheres are similarly charged. Then the electric field is repulsive. This is the electric field. We have done this in O level and A level. And this is the neutral point. Mean electric field strength here is nothing, 0. So now we have to draw electric field strength for two similarly charged sphere. This is electric field strength. This is horizontal line distance. So from center to the surface, there is no electric field. This is the radius of this positive charge, this side. At the surface is maximum directed towards right. So it is considered positive maximum. Now move to this. This is the surface of the other positive charge. So till the surface it's 0. It is directed towards left. So it is maximum, but in the opposite direction. It's a vector. And this is the point, neutral point. So here is the 0. So join them. This graph and this graph. Now, this is the electric field strength graph when both charges are positive. Now, suppose both charges are negative, then the shape of the graph will be this. This side. This side, this is neutral. So this is the electric field strength and the distance graph when both charges are negative. Now suppose this is the line. This point is A, this point is B, this point is C. Positive charge is placed here, positive charge placed here, this distance is X, distance is X, and the question is calculate resultant E here at C. So first step, we will calculate E due to A at C. So the formula will be E is equal to 1 over 4 pi epsilon naught Q divided by x square, because distance is x, charge is q at way. And similarly, number 2, we will calculate E at C due to charge at B. So it is E is equal to 1 over 4 pi epsilon naught Q divided by, again, x square. Now the question is, for the resultant, whether they are added or subtracted. So these are the individual E's at C due to A and B charge. For this, for the decision of addition or subtraction, we will place here the test charge at C, and the test charge is always positive. Now this test charge will experience force due to this positive point charge in this direction. And this point charge will also exert force on this in this direction. So the forces are in the opposite direction on the test charge, so they will be subtracted. So for the resultant, we will subtract E due to A and E due to B, so the answer will be 0, mean there will be no resultant electric field strength between the two positive charges. Same here. Look, no electric field. But if the question is, this is the position of positive charge, this B is the position of the negative charge, and this C is the point. It is x distance from Q, A, and x distance from minus Q, mean B. Calculate the resultant electric field strength at C. So, number 1, electric field strength at C due to charge at A, E is equal to 1 over 4 pi epsilon naught Q divided by x square. And number 2, electric field strength at C due to charge at B. So it is E is equal to 1 over 4 pi epsilon naught, so it's magnitude Q divided by x square. This is the polarity. So we will write Q. Now, for the resultant electric field strength, again, we will place here the test charge at C. This positive charge will repel. This negative charge will attract. Both forces are in the same direction. So the resultant field strength is E due to A plus E due to B. So we will add them for the answer in Newton per Coulomb. Now, number 3 situation. If this is the line, this is A, this point is B, this point is C, this is positive charge, this is negative charge, this distance is X, distance X. Now, resultant electric field strength at C required, which is right side of the both, A and B. Now, electric field strength at C due to A will be equal to 1 over 4 pi epsilon naught Q divided by D square. So the distance between C and A is X plus S, it's 2X square. And number 2, electric field strength at C due to B is E is equal to 1 over 4 pi epsilon naught Q divided by X square. So these are the two answers. One for E, A, other for B. Now for the resultant at C, we will again place here the test charge. Now this point charge positive will repel it. with a small force due to the larger distance. And this negative point charge will attract it with a large force. So both forces are in the opposite direction. So resultant is equal to the difference of both E's. Mean we will write either EA minus EB or EB minus EA. So it's a vector. So we will decide addition or subtraction by placing the test charge at that point. Similarly, suppose there is a triangle, equilateral triangle. This is A, this is B, this is C, positive charge here, negative charge here. And all distances are x. Now, at C, resultant electric field strength required. So this is the distance. So number one, electric field strength at C due to A will be 1 over 4 pi epsilon naught Q divided by x square. And number two, electric field strength at C due to B is E due to B is 1 over 4 pi epsilon naught Q divided by again x square. Now we have to add them. Look, if the test charge is placed here, this positive will repel in this direction. This negative will attract in this direction. Then we have to add them by head to tail rule. Look, 1E we will draw in this direction, which is EA, and then we will draw other EB in this direction. Suppose this is EB and EA. So this will be the resultant. For example, this answer is coming 4 Newton. This answer, a Newton per coulomb, and this is coming, suppose 3 Newton per coulomb. We will write here the scale. 1 Newton per coulomb is represented by 1 centimeter. So this is 4 centimeter, this is 3 centimeter. Then we will measure this resultant because electric field strength is a vector. So we add them, we will add them by head to tail rule. So this is very, very important.